Shannon Moore, 4/3/2025. First, I started with 1.000 grams of citric acid, C6H807. I calculated the number of moles by dividing the mass by its molar mass, which is 192.124 grams per mole. This gave me approximately 0.00520 moles of citric acid. Next, I used the balanced chemical equation, which shows that 1 mole of citric acid produces 3 moles of carbon dioxide. So I multiplied my moles of citric acid by 3 to find that I could theoretically produce about 0.0156 moles of carbon dioxide. Finally, I converted the moles of CO2 to grams using the molar mass of 44.01 grams per mole, which resulted in a theoretical yield of approximately 0.686 grams of CO2. Now I have my beaker filled with 30 milliliters of water. Drop in my Alka-Seltzer tablet. As soon as I drop the tablet into the water, I can see immediately bubbling and fizzing. This is carbon dioxide gas being released as the tablet dissolves and reacts. Now that the reaction is complete, I observed that the bubbling has significantly decreased and the solution is clear again. The Alka-Seltzer tablet has completely dissolved and there are no visible solid particles remaining in the beaker. The solution looks similar to how it was before, with a few bubbles still in there. I know that the carbon dioxide gas has been produced and escaped into the air. I now record the final mass of the beaker in water to determine the amount of CO2 produced. In this trial, I calculated the percent of yield of carbon dioxide produced. For trial 1, I obtained a yield of 100%, which means I achieved the theoretical yield perfectly. In trial 2, however, I measured a yield of 116.6%. This suggests that the product may have been impure or that there were errors in my measurements. In conclusion, while both trials were interesting, trial 1 was more reliable since it matched the theoretical yield exactly.